Sound travels in waves, like ripples from a penny dropped in a bucket of water. Once sound is created, a tick, a tock, a clap, a boom, a whisper, a crackle, a crash, a zoom. Its energy rides upon the crest, doing what any wave does best, traveling through air, water, or even solid until its energy is finally used up and the noise fades to quiet. The sound flattened to stillness, not making a peep, until that dog next door barks, setting off another wave, waking you up from your sleep. Hey everyone, today we will be conducting the string telephone experiment. But before we get into the experiment, let's think about what we've learned so far. Light and sound, as previously explained, are waves of energy that we sense. When these waves interact with materials, they change, which then affects how we hear and see. One example is how sound travels and loses its energy when interacting with materials. Sound moves through materials in vibrations we cannot see. This is called transmission. As it travels, some of its energy is absorbed by the material, making the sound quieter and less clear. This is called absorption. The string telephone experiment investigates and proves that sound travels through vibrational waves along a medium and that changing the medium changes the sound. For this experiment, you will need 4 paper cups, 1 2-meter string, 1 1-meter string, a sharp tool, and a partner. Procedure. Step 1. Make a small hole in the bottom of each cup, as displayed in the video. Step 2. Thread each side of the 1-meter string through the hole of 2 cups, as displayed, remembering to tie a knot so the thread doesn't come loose. Step 3. Repeat the threading process but with the remaining 2 cups and the 2-meter string. After step 3, you should have 2 string telephones. The first telephone should have 1 meter length and the second telephone should have 2 meters length. Follow steps 4 to 7 when conducting the experiment. After conducting the experiment, the clarity and volume of sound heard was rated on a scale from 1 to 10 by each partner. 10 means a very clear and loud sound was heard, 1 means no sound was heard. The recorded results are displayed in the provided table. The observations made were that the 1-meter string telephone produced a clearer and louder sound. The 2-meter string telephone produced a quieter and slightly less clear sound. Sound was easiest to hear when the string was pulled tight in both setups. When the string was slightly loose, the sound became more muffled and difficult to hear, especially in the 2-meter string. The results of this experiment showed that the 1-meter string telephone produced a clearer and louder sound than the 2-meter telephone, which was quieter and less clear. This suggests that sound vibrations are transmitted more effectively over shorter distances. As the sound travels along the longer string, more energy is absorbed, reducing its volume and clarity. These findings support the ideas of both transmission and absorption of sound waves. This experiment had 3 main limitations. First, it was hard to keep the speaker's volume the same each time. Second, it was difficult to keep the string equally tight in every trial. Small changes in these 2 factors could majorly affect the results. Finally, the results were based on personal judgment, not precise measurements, so they may not be fully reliable. This experiment has many real-world implications and applications. It demonstrates how sound can travel in waves through materials, specifically solids. This helps explain how telephones work and how sound can travel through solids like walls. The main safety risk of this experiment was the step where holes were punctured at the bottom of the cups. When conducting this experiment, make sure cautions are taken, such as supervision or adult assistance, to ensure safety. Several variations of this experiment could be explored to enhance the results and further scientific understanding. Variations such as using different string materials or cup materials would provide a deeper understanding to the behavior of vibrational sound waves and how they interact with materials. Overall, this experiment successfully demonstrates how sound travels in vibrational waves and interacts with materials.